Alright, so today's lesson is going to be on graphs of rational functions. We've already done a little bit of graphing rational functions, but today we're going to look at it a little bit more in depth. So let's go ahead and get started. First type of problem you might see are ones where you need to sketch the rational function and kind of compare it to the parent rational function. So the good thing about some of these is that they're essentially just transformations, whether you shift it up, down, left, right, flip it, all those types of things. So if you remember how we do transformations, then some of these should be pretty simple. So first you have to remember what the parent function of a rational function looks like. And we know that it's going to go through the point 1, 1, 1, negative 1. And it's kind of going to have this shape to it, right? Because when you plug in 2, you get a half. And you plug in 3, you get a third. So that line, as you go further and further to the right, and x is bigger and bigger, it gets smaller and smaller because it's 1 over 10, then it's 1 over 100, then it's 1 over 1,000,000. So those numbers get smaller and smaller as x gets bigger. Also, it does the same thing on the negative side. It's just going to be a negative number getting smaller and smaller. And of course, as x gets smaller and smaller, when you divide a fraction by 1, it makes it a whole number again. So that means that as you get down less than 1, your graph's going to get bigger and bigger. And of course, when it's negative, it's going to get to be a larger and larger negative number. So it's going to go down towards infinity and or down towards negative infinity and up towards infinity in those situations. So that's the parent function. So right here on h of x, you know how we talk about when you're on the inside, it moves it left and right, and when you're on the outside, it moves it up and down. So the inside right here is the bottom of your fraction. Okay, so whatever's, there's no parentheses, but it's understood that that's what the inside is because that's inside the fraction. So that minus 1 on the inside has got to move it either left or right. Of course, it's a minus, so minus moves it to the right. So that means our vertical asymptote now is going to be shifted right 1. So we're going to have this. And then plus 3 on the outside is going to shift the graph up 3. So instead of the horizontal asymptote being across at 0, vertical asymptote moved over 1, the horizontal asymptote is going to move up 3. So right there's where our asymptotes are going to be. Everything else about the graph is going to be the same. So if we kind of pretend that where those two asymptotes intersect is our origin, then you can see that's the point, that would be the point, 1, 1. If that was the origin, this would be the point negative 1, negative 1. So then you can kind of graph the function from there based off of those 2 points. Because it's the exact same function as the parent function, only we shifted it right 1 and up 3. All right, now on this next one, you got to look at your shift. So we got x plus 2. So that's on the inside. That's going to move it left or right. Plus 2 moves it left. So we're going to have a vertical asymptote at negative 2 now. The horizontal asymptote is going to stay in the same spot because we didn't shift up or down at all. But now this negative right here, okay, you got to pay attention to that negative. Remember when you multiply on the outside by a negative, it flips everything, okay? It flips everything across the x-axis. So that means that now instead of your points being at 1, 1, it's going to be down at negative 1, positive 1, negative 1. And instead of being at negative 1, negative 1, which is right here, it's going to flip to be up here, right? So those two values are now going to change locations because of the negative. It flips everything. So then you still got the same general shape, those L shapes that approach the asymptotes but never ever touch them. All right, so that would be the graph of negative 1 over x plus 2. So I'm going to pause it. You guys see if you can try the one down at the bottom. Let me know if you have questions. So on these last ones, I forgot you're supposed to describe how it relates to the graph of the parent function. So for the first one, we would say we go right 1 and up 3. And then for B over here, we'd say we go left 2 and reflect over the x-axis. So we got to describe how it relates to the original. So on yours, you should have made a graph that looked like this. This one's going to flip over the x-axis. It's also going to move left 2, and it's going to move down 1. All right, so that's what the graph would look like. Your asymptotes, of course, went left 2. The vertical one's left 2, and then the horizontal asymptote went down 1. And your points have to flip, so you're not up at 1 above and 1 to the right. You're 1 to the right and 1 down, and then the other one, of course, is left 1 and up 1 from the intersection of the asymptotes. All right, so now looking at some more complicated rational functions that you can't just shift the parent function, Okay, we've got to use these steps. So first we're going to simplify the function if possible, meaning factor and cancel things if they'll do that. Number 2, find and plot the y-intercept by finding f of 0. So we plug in 0 for x, right? Because if x is 0, then that means we're on the y-axis, so that will tell us the y-intercept. 3, find and plot the x-intercepts by setting the numerator equal to 0. So you find the x-intercepts, we talked about this already, by setting the numerator equal to 0. B, or a 4-part, you find and sketch the vertical asymptotes by saying denominator equal to 0. Again, something we already know. Number 5, this got to find the horizontal asymptotes or slant asymptotes. Slant asymptotes is something new we'll talk about today, but you already know how to do horizontal asymptotes. And then 6, plot at least one or more point between and beyond the x-intercepts and vertical asymptotes. So we need to find some points in between all those asymptotes and x-intercepts. And the last thing is use smooth curves to complete the graph between and beyond the vertical asymptotes. All right, so that seems like a lot, I know, so we'll go through it one step at a time on a couple of problems. Okay, so first we need to simplify the function if possible. Well, you can't simplify this because there's nothing that'll factor up top or bottom. So we can't really simplify, nothing will cancel out. All right, so first find and plot the y-intercept by finding f of 0. All right, so to find f of 0, we're going to plug in 0, or in this case g of 0. So we got 3 over x, or sorry, 0 minus 2. So g of 0 equals 3 over negative 2, negative 3 halves. So that's negative 1.5, which would be right here. So this is going to be our y-intercept. That was step 2. We didn't have a step 1. Step 3, find and plot the x-intercepts by setting the numerator equal to 0. Again, we already know how to do this. So step 3, we set the numerator equal to 0. We say, oh, well, 3 cannot equal 0, therefore there are no x-intercepts. We don't have any. Next step, we're going to find and sketch the vertical asymptotes by setting the denominator equal to 0. So let's put the denominator equal to 0, x minus 2 equals 0, and solve. We get x equals 2. So that means we have a vertical asymptote at 2, where x equals 2. So we can just draw that on our graph. Step 5 says to find and sketch any horizontal or slant asymptotes. Okay, so all we know right now is about horizontal. We'll do slant ones later. So horizontal asymptotes. Well, we got the degree up top is 0. The degree on the bottom is 1. So we know when the degree up top is less, right? Up here it's less than this one. Then that means we have a horizontal asymptote at y equals 0. So we can go ahead and draw a horizontal asymptote right here at y equals 0. And next, we need to plot at least one or more point between and beyond each x-intercept and vertical asymptote. So we don't have any x-intercepts. All we have is one vertical asymptote, right? So we need to plot some points on each side of the vertical asymptote, right? So plug in some values and figure out what we would get with those values when we plug them in. So if the vertical asymptote's at 2, we can plug in 3. So we got 3 over 3 minus 2. That gives us 3 over 1, which is 3. So we plug in 3, we get 3, right, which is way up here. And then we can plug in some other ones, maybe, I don't know, 6. So there's 3 over 6 minus 2. That's 3 over 4. So we get 3/4 when we plug in 6. 3/4 would be somewhere right in here. All right, maybe we need one in between there too. So let's do 4. 4 over 6 minus 2. That would be 4 over 4, which would be, 3 over, goodness gracious. It's early, guys, sorry. 3 over 4 minus 2 would give us 3 over 2. So 1.5 when we plug in 4. And if we plug in 4, or plug in 5, we would get 1. So that'll give us some points that we can, rely on to draw our curve a little bit on that side. Now let's find some points that are negative. So maybe plug in negative, or a positive 1, because it's on the left side of the vertical asymptote. So 3 over 1 minus 2. That's 3 over negative 1, which is negative 3. So we plug in 1, we get negative 3. And then maybe something out to the other side of the y-intercept, so let's plug in maybe negative 2. So we got 3 over negative 2 minus 2 would be 3 over negative 4. So negative 3/4, and plug in negative 2. So negative 2, negative 3/4, somewhere in there. All right, so you can kind of see how this graph is going to look. All right, so then you connect it with smooth curves. That's the 7th step, and you're done. All right, so that's essentially how you do those problems. Follow each of those steps one at a time, get your points, and then plot some more points, connect them with a smooth curve. So let you guys try this one right here. Let me know if you have questions. All right, so on this one, first you figure out simplify the function if you can. You cannot simplify anything on here. Some of you might think, oh, well, you can cancel those x's out, but you cannot do that because 2x is connected to the -1, so you can't cancel through terms. If the -1 wasn't there, yes, you could cancel those x's. Then on number 1, second step, you've got to find the y-intercept where you plug in 0, and it makes you divide by 0, which is undefined. So you don't have a y-intercept. Next step is to set the numerator equal to 0 to find the x-intercepts right here. So whenever we do that, we solve and get x equals 1/2. So you have an x-intercept right over here at 1/2. And then you've got, let's see, right up there is 1/2. So then you've got to set the denominator equal to 0. You got x equals 0. So that gives us a vertical asymptote right here where x equals 0 going straight up. And then we've got to find the horizontal asymptotes. Well, the degree of the top is 1 and the degree of the bottom is 1. So since they're the same, you look at the coefficients on the top and bottom of the function. The coefficients are 2 and 1, so your horizontal asymptote is at y equals 2 over 1, which is 2. So y equals 2, we draw us a horizontal asymptote across 2. And then number 6, you just plug in some points on either side of your asymptotes to figure out the behavior of the graph. So I plugged in 1 and 3, -1 and -3. If you plug in some other points, that's fine. And then connected all the points with a smooth line that approaches the asymptotes. All right, let's do some other ones that might be a little bit more complicated. So right here, we need to do the exact same steps. So first, we're going to simplify. So on this one, we actually can factor the top and bottom. Well, we can the bottom anyway. So the top doesn't factor, but the bottom will factor. Doing our x box, right? We'll multiply to be 2 and subtract to be 1 to get 2 and 1. So we got x and 2, we got x and 1. And then we have a minus on the big number, plus on the small one. Okay, so now when we factor, will anything simplify? Can anything cancel out? No, we can't cancel x on top with anything on the bottom because there's not an x just by itself. If we had, I'm going to have to erase this, so you might not want to write it, but if I just had an x right there, then yeah, I could cancel out the x that's on the top with the x down there on the bottom. But not when the x's are attached to a number with a plus or minus. Okay, so that's simplified. Second step, to find the y-intercept. So if I plug in 0, I got 0 on top. Down the bottom, I got 0 minus 2, 0 plus 1. So it's going to be 0 over -2 times 1, or 0 over -2, which is just 0. So I've got a y-intercept at 0. And plot that. Set the numerator equal to 0 to find the x-intercepts. X equals 0. All right, so the x-intercept's also 0. We already got that point plotted. Your x-intercept and y-intercept at the same spot this time. 4, we're going to set the denominator equal to 0, which I'm going to use my factor denominator because if I'm setting it equal to 0, I'm going to have to factor it anyway. So now whenever I set this equal to 0 and solve, I'll get my vertical asymptotes. So I'm going to have x minus 2 equals 0 and x plus 1 equals 0. X is going to equal 2 and x is going to equal minus 1. So I'm going to have 2 vertical asymptotes, one at 2 and one at minus 1. So let's graph both of those. One of them's right here at 2 and one of them's over here at minus 1. Right, those are my verticals. Now, step 5 is to find the horizontal asymptotes. So to do that, you check the degree. The degree up top is 1. The degree on the bottom was 2. So since the degree up top is less, right, that means you're going to have a horizontal asymptote at y equals 0. So our horizontal asymptote will go right through here, y equals 0. And you're saying, well, wait, you said it can never touch that. No, it approaches it, right? So right here we have a point right there, but our graph is going to approach the asymptote, okay? So it's going to get closer and closer to it at some point, even though it touches it at that point. There's other points it's going to get closer and closer to the horizontal asymptote. All right, so step 6 is to plot some points. Now, we have 3 sections of our graph, right? Because we have 2 vertical asymptotes, so let's split it into 3 sections. We've got to figure out what it does on all 3 sections. So we need to plug in some points on every side. Okay, so we've got 0 right here in the middle. Let's take care of the middle first. So we got 0, 0. Let's plug in 1 and see what happens. We get 1 over 1 minus 2 times 1 plus 1. That's going to be 1 over negative 1 times 2. So that's going to be 1 over negative 2. So we get negative a half when we plug in 1. 1, negative a half.